Hello and welcome. Today, we are diving deep into the incredible, invisible, and super chilled world of liquefied natural gas. We're going to break down exactly how this really crucial energy source makes its amazing journey across the entire globe, from a gas field somewhere all the way to our homes. Okay, let's get right into it. So, it all kicks off with this really fundamental question. Natural gas is, well, it's a gas, right? It takes up a huge amount of space, which makes it pretty much impossible to just load onto a ship and send across an ocean in any kind of efficient way. I mean, sure, pipelines are great for moving it across land, but what happens when you need to cross an entire ocean? How do you solve that puzzle? And this is the magic number that changes everything. Negative 162 degrees Celsius. Just to give you an idea, that is colder than the surface of Mars. It's ridiculously cold. Getting natural gas down to this temperature is the absolute key to solving that whole shipping problem. But why? What does being this cold actually do? Well, at that incredibly low temperature, natural gas does something amazing. It goes through a total physical transformation. It changes from the gas we can't see into a clear, non-toxic, totally colorless liquid. And that liquid is what we call LNG, or liquefied natural gas. Now, what's really important to remember is that this process doesn't change the gas chemically at all. It just changes its physical state. And here is the mind-blowing payoff. In its liquid form, natural gas shrinks down to just 1/600th of its original volume. I mean, think about that for a second. Imagine you have enough natural gas to fill a giant beach ball. If you turned that into LNG, it would shrink so much it would fit in the palm of your hand, about the size of a ping pong ball. And that massive compression is the secret sauce that makes shipping it across oceans economically possible. So here's the game plan for our journey today. We've just covered the basics of what LNG is. Next up, we're going to look at how it's actually bought and sold on the world stage. Then, we'll dive into the amazing technology that makes the trip possible, how it gets turned back into a gas, and finally, why any of this really matters for our global energy supply. All right, let's switch gears and talk about the money. Turning gas into a super chilled liquid is all science, but getting it bought and sold, well, that is the art of the deal. LNG is a massive global market, and it has its own really complex set of rules for how it's traded between different countries and companies.
So it's super important to get that not all LNG deals are created equal. They're usually classified in three main ways. First up is duration. A deal can be for a single immediate shipment, which is called a spot cargo, or it can be a massive contract that lasts for decades. Second, you've got the delivery mode, which basically decides who's in charge of the shipping. And finally, there's pricing. It can be a fixed price, tied to an energy index, or some kind of mix of the two.
And this shows you the legal nuts and bolts of the whole trade. The big one is the SPA, the sales and purchase agreement, for those huge long-term deals. But a really important part you'll see in those contracts is something called a take or pay clause. This means the buyer has to pay for the agreed upon amount of LNG, even if they don't actually end up needing it or taking it. And you might wonder why. Well, it's because these liquefaction plants cost billions of dollars to build, and this clause guarantees the revenue they need to get the financing for such a massive project. Now, here's a totally different kind of arrangement. It's called a tolling agreement. In this setup, the liquefaction plant doesn't actually own any of the gas itself. Instead, a company with its own natural gas brings it to the plant and just pays a fee, a toll, to use the facility and get its gas chilled into LNG. So the plant basically acts like a factory for hire. Okay, so the LNG is made, it's ready to go, but who's in charge of booking that incredibly specialized, super expensive ship? Who's responsible for that cargo if something goes wrong out on the ocean? Well, all of that is laid out in a set of international commercial rules known as Incoterms. Now, this table here breaks down the most common Incoterms you'll find in the LNG world. And yeah, they might look a little complex at first glance, but really, they all just answer two very simple questions. First, where does the delivery officially take place? Is it at the port where it's loaded or the port where it's delivered? And second, and this is the big one, who is responsible for the transport? Let's make this even simpler. Let's just boil this all down. Under what's called an FOB, or free on board contract, it's the buyer who has to arrange and pay for the ship. The risk becomes theirs the second the LNG is loaded. But with DES, or DAP, the seller handles everything. They take care of the shipping and are responsible for getting the LNG safely all the way to the final destination. In the end, it really just comes down to one simple question. Who hires the boat? So we've talked about the deals. Now let's talk about the tools. I mean, moving a liquid that's negative 162 degrees Celsius clear across an ocean, that takes some of the most sophisticated and impressive engineering technology on the entire planet. So the journey itself starts at that liquefaction plant. From there, the main way it travels long distances is, of course, on those massive LNG ships. But for smaller scale deliveries or for moving it inland, the LNG can also be put into special cryogenic trucks or even these standardized ISO containers. They kind of look like regular shipping containers, but they're built to handle that insane cold. These LNG carriers are just absolute marvels of engineering. The best way to think of them is as giant floating thermos flasks. The LNG is stored inside these enormous, super heavily insulated tanks to keep it at that critical temperature. And the two main designs you'll see out on the water are the more boxy-looking membrane tanks and those really distinct, iconic spherical moss tanks. Now, here's something really clever. No insulation is absolutely perfect, right? So over a long trip, a tiny amount of the LNG is naturally going to warm up just enough to evaporate back into a gas. This is called boil-off gas, or BOG. But here's the brilliant part. Instead of just being wasted, this gas is actually captured and piped directly to the ship's engines to be used as fuel. It's an incredibly efficient system that literally turns a potential loss into free fuel for the journey. So, the ship has made it across the ocean. The LNG has arrived. But you can't just pump a supercooled liquid into a city's regular gas pipelines. There's one final crucial step. You have to turn it back into its original gaseous state. Okay, let's clear up a really important bit of language here so things don't get confusing. We started with natural gas in its gaseous state. The process at the end of the journey, where we turn the liquid back into a gas, is called regasification. It's exact mirror image of the liquefaction that happened at the very beginning. So the process itself is actually very straightforward. At what's called a regasification terminal, the liquid LNG is very carefully warmed up, usually using seawater, until it converts back into its gaseous form. From that point, it's just regular natural gas, and it's injected right into the local pipeline network, ready to be used. And that is the final step that completes this global gas journey. We've followed the contracts, we've looked at the ships, we've covered the science. But why? Why does this incredibly complex, really expensive, and super chilly journey matter so much to all of us? Let's connect it all back to the real world. Well, once that LNG is regasified, it's the exact same natural gas that millions and millions of us rely on every single day. It's used in power plants to generate electricity for our grids, it heats our homes and cooks our food, and it's a vital fuel source for all kinds of major industries. And that really brings us full circle, right back to the fundamental purpose of this whole thing. This quote says it perfectly. The entire multi-billion-dollar global LNG industry really exists for one simple reason: to get natural gas to places that pipelines just can't reach. It's all about connecting energy supply with energy demand across the world's oceans. And that leaves us with one final big question. LNG gives countries incredible flexibility. It acts like a global energy bridge. But as the world is trying to navigate a very complex energy transition, LNG finds itself in a pretty contentious spot. Is it a cleaner bridge fuel that helps us move away from coal? Or is it something that locks us into decades more of fossil fuel emissions?